if there is a positive side and negative side. Okay. We are giving the high voltage. If we are giving high voltage from positive and negative, means what will happen?
It will attract.
There will be an electrostatic force. You will see in normal wires now. There are some wires, if there is no touch, means there will be one spark will create. The same spark will create there. But we are putting the solution, the spark will accumulate in the solution. Positive side is there, negative side is there, but it won't be touched. But it should be finished. It should be finished the circuit. For that, it will create a one vaporized plasma. The positive plasma will be based on accumulate on the solution from this place. Okay, this place is the electrical. Normally, when we push the liquid outside, means the charge is there now, positive charge. It automatically directly go to the negative electrode, right? Positive to negative will go. Like that, it will go, means it will deposit on the negative electrode side. Okay. This is the understanding. We are giving the, it won't happen in the small, the plasma it should create. For that, we will give the 12 volt, 13 volt, 15 volt, 35 volt, 15 kilovolt, sorry, not volt, kilovolt you will give. Okay. This is based upon your material. If your material is a highly conductive material, you will just give 1 volt, 1 kilovolt, 2 kilovolt, means it will complete the circuit. It will complete the, it will set the particle to that side. If your material is purely PVA, it's a non-conducting material, or pure water. Or else non-conducting material means we will go to the higher kilovolt, like 50 kilovolt or 45 kilovolt, 50, 60 kilovolt. Here we are applying 35 kilovolt.
That is the maximum.
Yeah, that's the maximum. But for our material, if the material don't inside means material is not a material, it's only PVA. Okay. Some polymers have in the piezoelectric coefficient, like PVA, those kind of polymers. But PVA is not. But PVA is one of the piezoelectric material. That's why we are taking the PVA as a material. And already we prepared the solution with the DMF and the PVA, 10%, 10%. 10 gram of DMF or
DMF solution.
1 gram of PVA, 10 gram of 10 ml of DMF. Like that, 10% we done this one. Already 70 degrees Celsius we stirred for a whole night. It will disperse, this one.
So it is a gel, right?
Yes.
So how it becomes, because DMF is a normal liquid.
Yeah, DMF is the polymer. It's a normal solid polymer. We will mix it to get the matrix. And we will use DMF.
So only in polymers only we can get this type of gel, or I can use any magazine. We can only polymer materials we can
somewhat polymer materials should be there. Then only what will be happening here, elongation is to be happening. Your material can't be able to put the elongation to get the fiber. Okay? But this slurry is very important. It should not be more liquid, should not be more slurry.
Yes.
Okay? Because it won't be, can't be able to inject outside. Okay? And if you it will be very liquid means, I already told, it won't be get the fiber. It will deposit as a particle and the water drop will be separate and it will come down. Okay. Now we are going to set up the friction test.
Sir, it is
We are taking from syringe, right? We should not touch your solution. Why you know? Because if your syringe have that strip, right? 1 mm, 2 mm, 3 mm, 4 mm, it's a DMF. It will easily solve it. We can't able to see how much mm is going on, still how much mm is there, and your material also get impure. Okay, that's why this edge only should be touched. After getting this one, you definitely got the bubbles. If the bubble is there, means your fiber won't be a same. Your fiber won't be the same. Okay. For that, this bubble we should remove first. Whatever the material, if it is a PVDF, that's why we get the bubble in top side. If your material is having means, it won't come like this. It easily coming out from liquid like that. You just did like this, means it will come to up. After this one, slowly we remove it. I will say there is nothing. Nothing here but is there. This is pure. After setup, everything is done, then only we will put the needle. Before that we should get because we will injure by that. Okay.
We are measuring how much amount we are using this input.
Is that
Now you are taking
correct? Is that correct? Like that you will, if 5 ml syringe is there, 10 ml syringe is there, how much you want, that much syringe you will just take on.
I need 5 ml means we are using only for 5 ml syringe or it is 10 ml syringe also.
10 ml syringe also will use. 12 ml syringe, 2 times we will use. Because the solution is sprayed. That's a concept. Base electrode on the collector, because if this is the positive side, this is the negative side, right? If you place any polymer or any non-conductive plate like that, the electrode you will place means the electron will come from some other way. It won't come from this way. Then your polymer or your fiber will create on any other side of the plates, or else it is based on here or some other place. It should be metal. Is a copper, is not only a aluminum foil, it should be any metal. Copper foil is there, aluminum foil is there, like that, any other foils. Then only we should connect and we will connect. If in case of we want only one separate place means the collector will be there, plate collector is there. This is the round collector, plate collector is there. Just we will paste the aluminum foil, then it will collect. Okay, at one place. But we are using for some other application for flexibility for the.
So here we have to give some arguments.
The plate means only one place it will connect. We can use plate here. No. That's what plate is there. This is the plate collector. We just place the aluminum foil here. This one plate it will be collect. Okay. For like FTO plate is there now. For the FTO plate we can't able to place here because it's a round, it's a solid. For the things we will use this. Okay. It's a good question. Because aluminum foil front side is a very smooth surface is there. What is that? Our fiber want to be deposited and attached with them. If we are using the aluminum foil means we just cut and use. It won't be stretched, it won't be fixed on that means normal surface now. A smooth surface it won't be attached. Then we can't able to get the output properly. That's why back side we are using. It's a somewhat rough surface will be there. Okay. We should connect the high voltage. Before we shouldn't do the high voltage.
Any specific distance for
Yeah, it's a 15 centimeters. Because we will, no, it's optimized. Just you take the when how much time you will do?
This is the
Need this collector. This collector how much distance? And that distance should be optimized by us. Because
already is there in
because the distance also we can change. But why it should be optimized means for every polymer, for every our material it will be varied. Okay. This one is there now. This is movable. This plate is movable. From that you will adjust the distance. 15, 20 centimeter or 10 centimeter, how much we want. From this we will adjust. Now come out to this way. Yeah, I will do that. Come and see here. You will get more thicker. If it is 0.1 ml per hour means you will get more thinner nanofibers. Based on our flow rate and timing, everything it will be optimized. Okay, it's more depends on the flow rate. If it is 1 ml or 5 ml per hour, 10 ml per hour also we can do. But for 10 ml per hour we will do means you will get the microfibers. It not should be up to the nano level. Okay, 0.1, 0.2 or 0.01%, 0.01 ml per hour we will do means we will get ultra thin nanofibers. Okay, this depends upon flow rate and current. Flow rate is here playing a major role. 0.5 ml per hour. We are doing actually we have to use for 0.5 ml per hour.
So what are the various parameters?
Right. Is that 2 ml? How many ml is that? That syringe is that 2 ml is that? 2 ml is the diameter of the syringe. Okay, it's a 10 ml. Because it will push now, then it will calculate how much time we will do. Because every syringe it will be varied. 10 mm, 30 mm, 15 mm like that it will vary. This diameter is 10 mm. Before we on this one, we should ensure the liquid is drop or what. Because there is no clot is there. In the needle there is no clot. It will come properly. Then we will turn down. After finish everything, here I give run, right? This run I will give means how many seconds it will be take more long. It automatically it will calculate. After that we will switch on the high voltage on. From here we will optimize the kilovolt. How much kilovolt? Here we optimize for 16 kilovolt.
So we can straightly go to 16.
No.
Step by step.
We should do by step, but we optimized for this one.
What I'm asking, some instrument they have to tell how to go by 1 volt, 2 volt like that. But here we can straightly fix. If we know optimize the
Because however you turn it on, it will go from 0 to 100%. It won't go to 60.
here there is no ramp.
From here you will see me the fiber you can able to see. Okay? Come and see me, so you come and see. Here the fiber you can able to see.
Has that weight
I'll change it. Color change the
Like that you will after that actually off, power off. Even though power off, everything will power off also. Electrostatic force, the power it will accumulate some charge. If you are place your hammer, it will end. This right? That's why we should ground everything. For that, this instrument they are giving. We should ground everything and every place. Importantly, this place. This is the high voltage place, right? Every place we should. Small touches are small touches. On the road. Actually, yeah. It is sprayed, but it cannot be much. Yeah, we should ensure every 1 hour or half an hour. Okay, it is spraying or not. Because the lot is there means it can't be sprayed.
Okay, sometimes we are not seeing this one, so after it is not sprayed. So what's the point?
Yeah, time will be changed. After that, we should change the timing.
Okay, we know about when it is started.
Yes.
So just after I will check it. So how I keep the time?
No, it's based on what? Just 1 hour you are taking. Or first you ensure fully.
When it is stopping, I don't know.
Yeah, when it is stopping, you don't know. First you finish the full time. After that you increase the 1 hour, 2 hour.
That time.
And after finishing everything, you get to know now how much ml is there. Because the
Okay.
strip is there, right? From that you will know, it will rotate. And it will move to here and there. If you set 5 cm means 5 cm will move here to there. But now it is not moving. No. But it will move from and back. Wait. Left to right. This one.
సార్ కొంచెం సైడ్
But it will start, it will move to here to there. You will ensure that it will correct every place. The same. That's it. Yeah, what is that? Okay. This helps me if you have any doubt on this.
You are wasting the half of
It's not any specific reason. Yeah.
in microwave.
Yes, non-insulative is fine. Because aluminum foil is there now every place. That is fine. It's for
Are also conductor, so any
yeah, that's why we are using. But in small place, you won't have anything.
So how much are they?
This is 150 RPM.
What is negative charge? So
Yeah, it will add. The solution will accumulate the positive charge. When it is pushed, the positive charge will go to there. Show me this. Yeah. This is finally outcome, how it will be. This is a PDF we already did one.
సార్
Tomorrow we will demonstrate that one. That time I will show how we will do this one. With the PDF or record.
I saw in super pepper stuff.
Yeah, super.
So how we are using, so maybe how we extract this one.
No, if you want to extract means, you normally you can able to extract. But it is not good to extract from this one. It will come. Okay, it will come like this. But after you,
the fiber is
yeah, after you get this fiber, you can't able to place anywhere perfectly. Okay, like that's why.
time is
Yeah, that's why what they will do means they will cut this one. They will use because it's the electrode. It's a material like that. However, you will go to place down one electrode, right? For that you are using this as electrode. More than this electrode you want to connect me, you go to copper. More than that you won't go anywhere. For SEM and all or XRD, we won't give with this one because aluminum will come because it's a
Straight go with the, I mean, you do the same with this signal.
yeah, not with this sheet, only this one.
You are going to do with the amplifier.
The XRD thing, if you are taking XRD, aluminum will come. Yeah, fiber won't come. That's it. There's a thin film XRD like that, you will go and this is the result of it. No, power flame.
so nanofiber. So any specific scale nanofiber.
Yeah, that's why we are going to sell.
Depends on
You will optimize means by the time you will optimize. Per
what I was saying. So depends on material or these parameters. I
Depends
need
upon-
5 nanometer per nanofiber means I keep this optimization for this one.
This
or-
one.
Any material,
not any material. Every material have different conductivity, right? Polymer have different, this material have different, copper has different, zinc has different types. Based on that, first we will do one thing, 1 ml per hour. If it is how it is come, based on that we should reduce or increase the ml per hour. We will ensure.
nanofiber synthesis for these two elements of synthesis, otherwise any other process.
Fiber is not only one method like that. Many methods are there. For example,
Some molecule naturally is nanofiber.
yeah.
But if you are synthesis,
The same syringe you will take and you will place your electrode on hot plate and you will place like that means it will come down. Like
any other method for synthesis. Synthesis are demonstrated.
oh, you are asking me about synthesis.
Any instrument.
Or you are-
Yeah, any instrument.
Yes, no, I would think. If you want to do means you will think and you will do.
What is the maximum speed you can reach? Not RPM. I am asking about the spray time. Flow rate.
That's
So what is the maximum we can?
no, we can do up to 2 ml per hour, not more than we will go because that time we will get micro levels, not in nano levels. That's why we are opting for 0.5. But if this instrument will go 5 ml per hour, I think so.
That is the maximum. Speed.
Now, here we are change anything means only we get nanofiber or sometimes it will be micro.
Yeah, micro. So depends upon the flow rate. But it's not only the only one thing we will do like that. Then we will see one instrument. Copper. Copper is there now. From that you are placed another one material also. It will come like 2 fibers at the same time. Intercalation of fibers. Because this also will spray. At the same time that also will spray.
Okay.
That we won't connect. The copper needles the copper needle we won't connect. If we connect the copper needle means the 2 polymers will come at same time. It will mix with the intercalation.
So how we treat this?
The pressing is there. Here downside is there, no? Downside. This side of that one.
Yeah, black color.
Black color. It will syringe from there and we need long pipe one. Long pipe. It will syringe. Like that we will do 2. From this we will do 2. But if you want means you will add another one, you will do the 3.
So you can do from this point.
It's fully controlled from there.
Is there any manual system?
Yeah, now it's also available. But it's fully controlled by the system.
So there is specific reason for the using this nanofibers.
Yes, if you are using the nanofibers, it will come like a thin wire. In the thin wire, our material will be there, like oriented. If you are using a nano material, basically you are doing a nano material, you can't able to get the proper. From this, the oriented will be there. That oriented will get higher up. Normal nano materials you are doing the same, you are doing the nanofibers, you will get more efficient.
This is other properties are any specific properties. For example,
Yes, depends upon our application.
material calculation.
Material calculation will change, but it will change the, it will enhance it. If it is oriented, it will enhance the process.
For example, solar cell is used, so this will enhance the optical output.
Like, I will tell you. Even here, you are there. Side ஒரு ஆள் இருக்காங்க, நேரா ஒரு ஆள் இருக்காங்க, சைடுல ஒரு ஆள் இருக்காங்க, நேரா ஒரு ஆள் இருக்காங்க. இங்க இருந்து ஒரு வாட்டர் பாட்டில் மேல போனாங்க. சைடுல ஒரு ஆள் போயிட்டு ஸ்ட்ரைட்டா கால் சைடுல போயிட்டு ஸ்ட்ரைட்டா கால் ரொம்ப லேட்டா நேருக்கு நேரா இருந்தானா வாட்டர் டக்குன்னு போவாங்க.
சைடுக்கு போறவங்களே மெஷர் பண்ணா
அங்க
ஸ்ட்ரைட்டா போறவங்க அவங்க மேல
ஸ்ட்ரைட்டா
என்ஹான்ஸ் ஆகும் காப்பர் கண்டக்டிவிட்டி இருக்குன்னா கண்டக்டிவிட்டி ஆல்ரெடி இருக்கும் அது என்ஹான்ஸ் ஆகும் சொல்லுவாங்க.
உங்களோட பார்ட்டிகல் இப்படி தான் ஃபுல்லாக இருக்கும். இப்போ இங்கேருந்து ஒரு எலக்ட்ரான் இங்கே வரணும்னா இது உள்ள இந்த ஹைட்டு வரத்துக்குள்ள ஸ்ட்ரைட்டாக இருந்தால் இங்கேருந்து வரணும் டக்கு இங்கேருந்து வரணும் ஒரே ஸ்ட்ரைட் பார்ட் there is no deviation.
இங்கே நம்ம கையில் வச்சிருக்கப்போ என்னன்னா கோல்ட் ஆகும் அந்த ப்ராப்பர்ட்டிஸ் கம்மியாக இருக்கும். ஸோ கம்மியாக இருக்கிறது ஏதாவது நமக்கு கூட தெரியும். ஸோ ஸ்ட்ரைட்டாக இருக்குது ஈஸியாக கிடைக்கும். அவ்வளோ கம்மியாக சேஞ்ச்
அது ப்ராப்பர்ட்டி இருக்காது சார்.
அதான் அது ரெண்டு கம்மி சேஞ்சஸ்
நம்ம சேஞ்ச்
அப்போ எல்லாம் ஜஸ்ட் ஒரு மெட்டீரியலோட எலக்ட்ரிக்
இப்போ நீங்கள் நார்மல் மெட்டீரியல் செக் பண்ணுறீங்க, ஃபைபர் செக் பண்ணிங்கன்னா அதில் அதிகமாக ஃபைபர்னால
So here, if you go for serpentine model, S-type model, zigzag model, X model, so whatever plane you can take anything, it has to be store as much as possible water in this channel. So where this design is the lay, push, load. Just you can check this one. Here it is find out the channels. So this we can call it as a flow field. So over this flow field, what we are using, just we are using one, just like it is like a membrane will be there. It's called Nafian membrane. Over that Nafian membrane, they will put one carbon cloth. In that carbon cloth, so what catalyst you are using, commercial available catalyst or what you are developing some catalyst. So that catalyst they will spray on the carbon cloth by using the spray gun. So that overall setup we can call it as a membrane electrode assembly. Where is the membrane will be there and two electrodes. That's called as a gas diffusion layer. Gas diffusion layer will be there and there over which we have put the catalyst. So this is the path. So one side what we do, we go for platinum catalyst or indium catalyst or ruthenium catalyst, something they will. Once it is a membrane electrode assembly is over, then they will place like this. They will place like this membrane electrode assembly. Place will like this, and this is the input of the water as well as the output of the water. So this water will be pumped by this peristatic pump. You can rotate that water 2 ml per minute, 1 ml per minute, 10 ml per minute, like that. The flow rate you can adjust with this pump. Once you adjust this pump, what will happen here? Once you assemble the cell like this, this is called as the current collector. So once you pass the water, it will fill the channels and it will exit. So these are the copper is the direct collector. Some people will use gold coated copper, or some people will use SS as the current collector. Some people will use copper. If you go for alkaline solution, they will preferable for the SS plate. If you are using for the PEM electrolyzer, you can use for the copper is the sufficient. So once it is there, then we can call it as an end phase. Over the end phase, we can coat on the FRC gasket. This is a fiber reinforced gasket to minimize to stop the conductivity between the graphite plates and the SS plates. Otherwise, what will happen? Cell will be sharpness. So to minimize that one, we will start with the and for the nut and bolt also, there is a over which there is a gasket. It is not direct nut. To minimize the electrical contact, there is a one heat sinks will be there on the nut to minimize the electrical contact. So where we can arrest the contact from here and we can arrest the contact from here. So only thing is we can get the contact from the center. That is called from the flow field. From the flow field means from membrane electrode assembly. So as long as you pass the water, it will enter and it will exit. So when it will break. So for that purpose, we have to give some particular potential to break the water. Generally, the ideal condition is it will be 1.2 just in an overall reaction. H2 will be there. H2 will be the anode side, cathode side. These are the things will happen. So here, if you as long as you pass water, so there is nothing will be happening. If you give some particular potential, the H2 will break, H plus and oxygen. So that OH bond will break, as I already told in the afternoon slide. So this is the old one. This is a new technology. It means where it does not require any titanium gas free layer or something. You can take direct carbon cloth. So right, titanium is too costly. The way we can go for the carbon cloth also to ready there right. So this is the drawing. So here what should we do? Applying for this one. So this is the load box. Just this is the load box. Where once you power on this one, where you can see what potential we are operating. So this is the graphite plate. It will withstand up to 1.8 volt. If it will cross, your cell will cross more than 1.8 volts, then start etching will happen in the graphite plate. Okay. So that is the one thing. So that's why we have to point out for if you are operating around less than 1.2 or something, you will go for the graphite. If you are using more than that, you will go for the titanium. Titanium is the low. So based on that, you can operate and you can study what is the catalyst loading. Generally, if you will operate 1.23, is the dissociative potential for the particular decay for 100 years or 100 hours, for 10 hours, what is the decay? 20 hours, what is the decay? 50 hours, what is the decay? And 100 hours, what is the decay? So why? Because like in two-wheelers, battery two-wheelers, what we are saying generally, so the battery life will be 3 years or 5 years guaranteed. It means even the laptop, the lithium battery what we are using, it is 1000 cycles. Whether you can say 2 years or 1 year or 5 years, the life cycle of the lithium battery is roughly 1000 years. So complete charging and one discharging, we can call it as a one cycle. So like that 1000 cycles is happening, automatically the efficiency of the battery gradually decreases. That's why when you buy the laptop, that time it will be videos of 4 hours, maybe after 3 hours, it may decrease to 2 hours, or 3 hours, or 1.5 hours, based on the usage. That is called after 1000 cycles. So here also same thing what will happen, as long as you continuously pass the water, the surface catalyst will be there, it is the powder. Once you make this powder, there is a hardness is there here. So that membrane at a particular temperature, maybe 100 degree or 150 bar, if you press it, all the materials will stick on the surface of the membrane. Once that membrane is still, so if you continuously pass the electron, what will happen? The layers of the carbon material slowly it will electrode. So that we have to study. After 100 hours, what is the efficiency? After 1000 hours, what is the efficiency? So based on that, we can say yes, our cell is withstand for 5000 hours, our cell will withstand for 10,000 hours. So like that, slowly they will do the. So this is the membrane electrode assembly system, where you can study the things, what is the efficiency and what potential we are operating and how much is the life is called stability state. And you can study with the same thing you can replace with an RPM membrane. So some people want to ask, see if I develop our own membrane or what will happen. So same thing, if you put your membrane and you will study with the existing RPM membrane. So RPM membrane 785 for example is 100% efficient. If you put your membrane, so how far efficient compared to the NAFIA? Maybe 50% or 60% or equal to the NAFIA. So same thing you can study. So that is the one of the possibility. So there is a possibility to do that. So this is the thing, it can be the temperature control. So why you need this one means, as long as if you send the cool water, it is very difficult to dissociate. So that's why before entering to this one, you need a small heating device. So like some heating system will be there. Like here, there is heating patch will come. So once heating patch will come, the cell will be heated up to 80 degree or 90 degree or something. Then what will happen? The water will come from liquid state to the vapor phase. So that vapor is entered into that one. It is very easy to dissociate in a particular condition. So this is the complete electrolyzer system where you can. So the system will change from small scale to large scale. Maybe this cell will produce 1 liter per hour or 2 liter per hour system. Maybe 1000 meter cube. The system and reaction mechanism is common. Only thing is here we are using 5 cm by 5 cm. They will go for 30 cm by 30 cm. So 5 into 5 is here. 25 cm square area whereas in 30 by 30 is 900 centimeters square. So that is the only thing. So before going to the 30 centimeter by 30 centimeter, 25 centimeter, 20 centimeter, so all these things we can study in the small scale. If it is happening into the 25 centimeters, generally people will go for 50 centimeters square area, then 100 centimeters square area, then they will go for 625 centimeters square area, 900 centimeters square. So this is the basic thing. So these are the overall step-by-step reactions. So as a based on that thing, if you develop some catalyst or if you want to study some numbers, so with this system, so what is the operating potential and what is the operating current, that basic information with this one you can get. So this is the simple basic system to run to know the catalyst properties in real time application. So where what we are doing in the pre-electric system like approach, cyclic voltammetry or potentiometer we are using, there you can get some information. So that is in the pre-electric system. Here it is concerned with the small working model. It is like a prototype. So still we can decrease to the next level. So these are the basic things. So yes, for any industry, so they will ask what is the components are there in the process. So these are the components. Based on the PEM or EM, the composability of construction will change. But basic mechanism is common and basic systematic procedure is common. So this is the electrolyzer setup where we can generate the hydrogen by electrolysis of almost 3 years ago. With my so this is the electrolyzer system. So for this electrolyzer, the basic requirement is the water should be a deionized condition, deionized water or double distilled water. So why? Because if you are not using the pure water, what will happen? The catalyst what we are using, it will cover it. It means the lifetime of this catalyst will be limited. So that's why people are using now seawater process. Seawater is a completely salty process. So now, after developing the membrane electrode assembly, it has to withstand if we send any water, like a seawater process, sulfide water, base water, whatever it is, the water if we send, the membrane electrode assembly has to be withstand for that water. That is the one. And some people are using for the US government is looking for the acid mine water. So during the mining, it's a lot of water is producing. So it's not like India, they cannot push that water into some rivers or somewhere. So they have to treat that one and they will release it to some rivers or ocean. So for that purpose, to treat that water, they are spending a lot of money. So what they are asking us, can you make like acid mine water sufficient electrolyzer system? The purification of this acid mine water, directly you have to send into the cell and it has to generate hydrogen. So that is these are the new areas like otherwise during the divergence or divergence are risky. There is a lot of wastewater. So like calcium water, so the cell should be withstand. So what is there in it? Before that we have to put a small purification unit according to the system and we have to use the stack. So these are the diversified applications we need to develop for the purification in the sense what should be water condition. Like if it is to go for hard water or some other thing, it's like a jelly type. So already flow channels, you look at the flow channels, it is a 1 mm thickness. So 1 mm depth and 1 mm width. So 1 mm width and 1 mm depth means water should be in a water condition. there is no ions or catalysts or anions or something. Even the acid like water, liquid water, water fluid, which should be in the same fluid, liquid form. So according to that, we have to make this membrane electrode assembly or this material. So that is the beauty of it. This is the one system for the electrolyzer. So based on it, capacity, the size of the cell may vary. So this is what we are developing now, and we are creating for the different places also for the complete system. So this is what my colleague Nagarajan and myself we established over this work when I am working in it. So that is the work. And second one is this one. We will explain explanation of it's called as a micromolecules. So there is a one more start. So hydrogen will be generated from the microbes. It's called microbial. We explain there. There are also same system will be there, but it is operating at very very low level. So low pressure. In this you can operate at high pressure also. But here you cannot do high temperature as well as the high pressure. So this is the Ballard-Mose problem. Yeah, please come.
కెమెరా రన్నింగ్ అబ్బాయి అబ్బాయి చూసుకున్నాడు.
Yeah, please come. You want break for some time? If you have any queries, just ask. Yeah, so here, yeah, there is a mass flow rate we will get. What is the flow rate? And what it is the operating rate? 800 degrees centigrade by 1000 degree temperature. So it is the condition. This is the reaction area where if you apply the two gases, one will be substrate and another one will be deposited on a particular substrate at a particular temperature. So the temperature and the particular substrate we have to optimize. So చెప్పాలా
మీరు వాళ్ళ వైపు అలా ఉండి చెప్పండి సార్.
So here what will happen? So with this carbon nanotechnology like single wall carbon use and multi wall carbon use and graphene material. So you can high pure graphene material you can synthesis here. But as a chemist or as a electronics, what are the main difficult formulas? As long as the temperature increases and pressure is increases, we cannot control or we cannot tune the property of the material or shape of the material. So like this hydrocarbon is there, into a particular is there. So it means at a high temperature, by applying some substrate, by applying the pressure, we are depositing on some nano material. So once we, after completion of this reaction, we can collect the material and we can put for where the material happens on the substrate. We have to keep here. That's what I am saying. Here inside. This is the area.
What type of substrate you get? Any conducting material?
No, it's not conductive. It's not transmitting. See, the thing is here. If it is a conductive means the substrate should not react on the surface. See, here dust particle is there. We are writing on the board. The people who are sitting on the ground, it will feel. So same thing will happen at a particular temperature. That solid particle has to be made into the vaporized form.
If I want to put the fluid, is it possible?
It is possible. But you have to put it inside. You have to keep it inside.
I do it same.
No. You have to ask only for carbon synthesis.
Only carbon.
Like that. No. Different condition means you have to know the particular condition. At what temperature aluminum is breaking. At what temperature is deposited. So CVD is meant we have to use like the follow. And we have to pass the acetylene gas. Acetylene contains the carbon molecule. This is yeah, please sir. So you can keep the IPO or something, but it has to withstand your temperature. So like black one is there, that is the board. In that board your substrate will be there. And you are passing the CH, the triple bond CH, that is called acetylene. Once you pass the acetylene, acetylene contains the two carbons. So that the acetylene gas molecule at a high temperature, the C and hydrogen bond will break. That carbon will be deposited on the substrate. So that material after particular temperature will remove from the substrate by cooling to the room temperature. The substrate and will do the analysis whether it is a CNT or carbon. That temperature and that pressure will have to be optimized in the system. This is the basic model of the chemical. Yeah, this is the silica board. Use the substrate. That's what different substrate we have to use. This is the board is to keep the material.
So on the top of that,
substrate system. Once you keep the substrate and you send inside, you pass the acetylene gas. At 800 temperature, the acetylene gas containing carbon will be deposited on the substrate. That substrate powder. See, a substrate is introduced into the quartz. Okay, there is some different substrates will be there, like what is silica quartz will be there, there is some different quartz will be there. In that quartz too, and export to the one or more volcanic process. So like that gas. If you pass at a particular temperature, that CH what is the gas is there, it is dissociated with the carbon and hydrogen. So that material you can collect it and we can so as you asked, we can further do film deposition, doping of the material, or coating of the nanoparticle on the substrate, or synthesis of carbon. Thin film deposition is like FPO or IPO glasses we can make. And what temperature or pressure it will be deposited. That we have to be optimized. Any carbon synthesis. So that is the, if you pass this way, there is a one flow will come. If you pass the other one flow will come. That is the basic thing.